Hello, welcome to the very last study unit in this module. It is study unit 9 on hashing. Although we are doing only a small introduction to hashing, you will come across hashing a number of times in your IT studies that's ahead of you. Most importantly, hashing is used in indexes in database systems. So when you want to do a lookup and you create an index on a table, you can do a quick lookup. And most of those indexes are implemented using hash tables. And it is with that in mind that we are going to focus on a specific aspect of hashing. So first of all, we are going to focus on what is important to know, to understand about hashing. And then we are going to look at how hash codes are designed, and then we are going to look at collisions. Once again, this is a small part of your textbook we are covering. It is more important for us at the moment that you have a thorough understanding of what is meant by hashing. The reason why we do hashing is very close to our hearts in this module, where we look at running times. If we do hashing, we can search, change, delete any direct operation in an array. We can do in order 1 execution time. Yes, you saw it, order 1 execution. Now it takes a while to understand exactly how it works. But once you get the hang of it, it is actually very simple. What is a hash table is always an array. Remember, an array has an index starting at 0. The main idea is to understand that the data you want to load in a database has a key field. Now, what is a key? A key is a field that identifies the record. Like my name is my key, it identifies me. Now a key need not be unique to be a key, it is just something that uniquely identifies a record. So if I, like my surname, which is Goede, hashing works by taking the key, in my case Goede, and do something with it, hash it, perform a hash function on it, and then it will end up with a number. I don't know exactly how that hashing number works, and then it knows that my information is stored at index number 4. And whenever we want to know where my information is, we just perform the same hashing algorithm on my name, and then it always yields the number 4, for example. Now with strings, we use the ASCII numbers to do the hashing, which we are not going to do in this semester. We can take the real value of the item. Let's take my age, which is now my current age is 17. So we can use my age, for example, as an input, but that's not necessarily a good idea, because although I stay every year 17, all the other people's ages change and they get older, like yourself, not like me, however. So age is not necessarily for other people than myself a good idea. Okay, so we can take some or other hashing function and convert, listen carefully, the key value. This is not it's the data entry, the value of the data. Convert it to a number which is used for the index of an array. And then we can directly access this number without searching for it. And this is the key difference from normal arrays, is we had to search. We could do it with binary search. That's why they said we could find it in order log n. That was if we would use binary search. But now with a hashing, we can do a single operation on the data to find the index. And therefore, search, insert, and delete is ordered one time. Isn't that cool? And now you know almost everything you have to know about hashing. Let's continue. We call this structure between the key and the index a map. And the entry is a key and a value. If I go back, I would store in this cell, I would store goede, that's the key, and the map is 4. I would store there, the index. Okay, a search key and a value. Now the search key, in fact, is the key that's used to locate the record. If you ever gone to a GP and they ask you when you reach there, what's your file number? As if you should know your file number. Now, they use your file number, which I never remember, as a key in the filing system. And once they get to that filing system, that position, they have all your information. Now, this is almost the case. It's just a little bit more clever. The key can be my surname, so that's something I would remember. It can be my ID number, something I would remember. ID number is better than a surname because it's unique. One small note, it doesn't mean the hashing function is unique, but that we will get later too. So a map is a data structure that contains a key value pair. So that map, the hashing table, is actually a map. So a dictionary can be a map, where the words are the keys, the word is how you get to the entry, and the definitions are the value or the translation, depending what type of dictionary it is. So a map we call sometimes a dictionary, or a hash table, or an associative array. So, but nowadays, according to our book, the term map is the in thing. Okay, so now let's carefully look at what is hashing. If you know the index of an element, not the key, the index, you can retrieve the element in order one time. We spoke about that. So can we store the values in an array and use the key as the index to find the value? Yes, that's the idea. We want to convert that key, the surname, the ID number, whatever identifies this record, we want to convert that into an index. Then we store it in an array called a hash table. But the function that converts the key into the index is called the hashing function or a hash function. So what is hashing? It is a technique that retrieves the value using the index obtained from key without performing a search. Do you clearly understand each part? Without performing a search. So we need not search the array, we will do it with direct access. And we want to retrieve the value, my surname, by using an index, the index in an array. And hashing is this process of converting the value of the key to the index of the array. Okay, here's an example from the textbook. The function first converts a search key, the function first converts a search key to an integer called the hash code, and then compresses the hash code into the index in the hash table. Sometimes two keys results in the same value. What are we going to do then if two keys have the same hash code? Then we need collision handling. That is a collision. And we are going to demonstrate two methods, linear probing and double hashing, just that you get an idea of what your options are. The textbook explains a number of them, but the idea is more important. Now, you can have a hashing function that will never have a collision, like an ID number, because the ID number is unique. But then you need a very long array, and that is called perfect hashing. The problem is you have a lot of open spaces in a perfect hashed array. Okay, now here we are going to also learn about hashing functions. Here's the idea of a hashing function. If you take your key and you do the modulus with n, where n is the number of items, you get the index. So let's say the key field is 26. Oh, I lied to you about the 17. 26 is my real age. So if we take the 26, my age, and perform this percentage or mod operation of 11, if I divide 26 into 11, I get 22, am I right? Remainder 4. So key modulus n gives you an index of 4. Now if I go to that 4, you can see there's already another one. There's already one that was age 4 there. That's a problem. So we can't use that spot because it's already occupied. Now in linear probing, we just continue to the next open slot. Oh, it's taken. Oh, it's taken. And now in this one, we will write key 26. We will probe 3 times before we get an opening. Now, obviously, this slows down the retrieval, but the idea is when I retrieve it, this key, I will find the 4 from the hashing formula, and then I will check the key at 4. Is it me? No. And then I will just do the same. I will probe the next entry, the next entry, the next entry, until I get the desired key. Double hashing says compute one hashing formula, and if you find a collision there, compute a different hashing formula. So we call it hash accent. So here the first H is, we mod it by 11, and then another function, the second function, if we have a collision, is 7 minus the key modulus 7. Now we use prime numbers for this. Can you think why? We want to have as many as possible unique answers. Okay, so for a search key of 12, let's say this example works with 12, so the first hashing gives us 12 percentage 11, which is 1. If I divide 11 into 12, 12 divided by 11, I get 11, the remainder 1, and that's where the 1 comes from. And now I will show you just now that it's already occupied. So I'm computing, by the way, the second function. I'm using this formula there. 7 minus 12, the key, modulus 7. Can you see why this is 2? What is 12 modulus 7? Yes, you are right, 5, because 7 goes into 12, 1, remainder 5. So 7 minus 5 is 12. Let's get to a diagram to see how this works. Okay, so I first compute for key 12 my hashing function, and I get 1. Okay, and there's already something, a 45. Oops, so I can't use it. I'm not using linear probing, so I'm not going to go to the next item. Now I perform the second hashing function, and you know that I will, if I do hashing on 5, I get 2. We just did that. That second formula was 2. But I add it to the result of my first answer. So I add it, and then I get an index of 3. And oh no, that's occupied as well with another one. And so I redo it, but this time, every time I redo it, I multiply my second one with a higher integer. So here I multiplied it by 1. So you can sort of say here I multiplied it with 0 of the second function, here with 1 of the second function, here with 2, and if I have another collision, I will multiply it with 3 of my second function. And here I have an opening, so I will write P and my own age of 12. I'm getting younger. Yes, there. Okay, and that's hashing. That's all you need to know about hashing. Let's sum up. Hashing is all about direct access of the data structure. You want to take a key, the name, any attribute which identifies the record, so it's cell phone number or something, but something you have readily at hand. And then you perform a formula which we call a hash function on that key to convert it to an integer. And then you need that integer as the index in the array. Now, you won't always have a, can you still remember it? A perfect hashing algorithm when there's no collisions, so you have to figure out how to deal with collisions. And we have done 2 ways, the linear probing of moving on and on and on, or double hashing. And that's it. Make sure you follow this video and you will be able to score high marks in the assessments. Thank you for participating in this course. I hope you learned a lot, and all the best with your summative assessment.